Hi everyone, and welcome to this technologycatalog.com webinar. My name is Vincent van Beuzenkom, one of the managing partners at technologycatalog.com. Today I'll be joined by Chris Janssen from AdVision for the presentation of the Carol robot, which we'll introduce in a second. As you can see, the webinar this time is in a different setting than you may be used to. Normally we present from our studio in the office, but also I'm working from home in this period. So it's a little less fancy setting today, I'm afraid. But I guess that holds for many of you that are dialing in today. At least I'm happy we can still continue with this type of communication and keep each other informed on exciting technologies that are being deployed around the world. The technology that will be presented to you today will be from the maintenance and integrity module of the technology catalog. Where it can be found in the submodule Industrial Cleaning and Decontamination. I've placed a star here to show you the Carol catalyst removal robot. But Chris will tell you all about that in a minute. Before I hand over to Chris, I would like to highlight the option on the right-hand side where you can type your questions that Chris will pick up after the presentation. Also, if you'll be watching this as a replay, you can type your questions either as a comment on the YouTube channel or contact Chris directly via the technology page in the technology catalog. Chris, I don't want to keep folks any longer. I think this is the time to perhaps introduce yourself, and thereafter I'll start your video.
Yeah, thank you, Vincent, and hi everyone. My name's Chris Janssen, and I'm the product owner for the Carol robotic catalyst removal technology. I look forward to presenting to you today and taking your questions, and I thank you for joining us. So there's a video of Carol, hopefully give you a bit of an overview of what it's all about. Let me start by just providing a little bit more background to why Carol was developed. And so I guess starting there a little bit more about myself. So I was formerly a process engineer at one of the big oil companies at a refinery here in Brisbane, Brisbane, Australia. And I was involved in the turnarounds for the naphtha hydrotreater reformer, and a part of that was catalyst unloading. And that's where I was kind of first exposed to the potential hazards involved in this process. At the company I was at, in fact, there was a fatality of a person in such a vessel. And for those who aren't sort of familiar with catalyst absorbance and the like, pretty much every petrochemical plant, refinery, LNG plant contains a number of these fixed bed catalyst vessels. Every couple of years, they open them up, they send people in to vacuum up the granular material and to replace it with fresh catalyst. During this process, people are sent down through manways that can be as narrow as 450 millimeters across in diameter, or 18 foot. And they go down into these vessels wearing special breathing apparatus because the environment must stay inert, because otherwise the catalyst will self-heat and ignite due to pyrophoric scale. So when I joined Worley 5 to 6 years ago, we recognized the need for and the opportunity to develop a tool to go into the reactors instead of sending a person in. And it was that which sort of started as just a seed funding from the Innovation Council, which has now gone through the design, prototyping, and commercialization. So we now have Carols operating in Canada, the US, Spain, Australia, and soon to have a job in Southeast Asia as well. So we're kind of looking to expand globally. So here's a overview of the system. So you have your reactor, and this might be sort of 2 meters in diameter, could be as wide as sort of 4 to 5 meters in diameter, and anywhere from maybe 5 meters tall to 20, 30 meters tall. It can have just a single bed of catalyst or multiple beds of catalyst. But you can see in the drawing instead of sending a person into the vessel, we lower our Carol robot. The robot's attached to a vacuum, and so the vacuum hose goes up and out of the vessel, and it's attached to the vacuum equipment. That's all the same as if it was either the robot on the end of it or a person on the end of it. Our technology is the Carol robot. We hook up to the vacuum hose, lower the robot in, and it sits on top of the catalyst. You would have seen in the video, it moves around using these augers. And so it's actually, this type of vehicle is called an ampherol. During the design process, the big challenge was being able to move on what is a very sort of fluid and almost like a quicksand type material. If you step on it, you're going to bury down to your knee because it can be so light. And so we needed something that could provide both a buoyancy and a turning ability. We didn't want to just vacuum in one spot and let everything kind of fall down to it, because sometimes you'll get clumps in there. You can build up a wall, and that's where it becomes really dangerous if you're sending someone in, because that wall can collapse on them. So hence we went for the ampherol type design, providing the buoyancy and the movement. The other elements that are shown in the drawing are the hydraulic power pack. It's all hydraulically driven, which was chosen to ensure that we could meet the ATEX Zone 1 rating requirements inside the vessel with the risk of explosion. It also has cameras, which again are ATEX rated, and then there's the operating module. So you can have the power pack on grade, kind of next to the vessel. Then you can have the operator sitting in an air-conditioned trailer, and or a container or whatever might make sense for that plant. And they'll operate the control sticks, they'll move the robot around, and they can adjust the nozzle using the cameras as well to ensure that they have maximum efficiency of catalyst removal. This operation can take anywhere from a few hours for smaller vessels to several shifts for larger vessels. So from a benefit perspective, we've been able to prove that the Carol performs as fast, if not faster, than a human worker. It's kind of, the limitation is the vacuum equipment. But the key aspect is that it doesn't require breaks. It doesn't need to come out of the reactor for lunch. All the time that's taken to suit up people, to put them in and get the confined space work permits, those are eliminated. And so if you're looking at operating over several shifts, then you can do split shifts across lunch, and you can essentially go from maybe getting 7 to 8 hours of vacuuming time to 10 plus hours of vacuuming time. And that's where we've seen significant benefits for the duration of the turnaround. And I guess, the real central idea around why it was developed, though, was from a safety perspective. And you're, in many cases, eliminating the need to have a person inside the vessel during the catalyst unloading. And that, of course, offers significant safety advantages. The specifications. So I mentioned the continuous operation. It also enables sampling of the bed at different points. So in some instances, these beds will be gravity dumped out the bottom. That has two issues. One is that you're left with the angle of repose, and someone needs to go into the vessel typically to vacuum that out. And then the other is that if you're having any issues with the bed, the process engineers can't really understand what's going on, because normally they'd like to take samples at different points in the bed. But because you're vacuuming the whole thing from the top, you're able to take those samples. As I mentioned, it's compliant from a hazardous area perspective, which is important for many clients. It's been tested on many different ranges of catalyst density, and that's where the real advantage over, say, a tracked vehicle has, because of the screws that I mentioned before. Another advantage is that you can put Carol in environments that aren't suitable for humans. It can operate at bed temperatures of up to 82 degrees and ambient temperatures of up to 55 degrees inside that vessel. That saves time in not needing to cool the vessel down as much. And then finally, it's a simple piece of kit. You would have seen in the video, it's just the robot. There's a gantry to lower it in. It's all very, it can be packed up quickly, shipped through on airlines from a cargo perspective, so we can get it anywhere quickly. And as I said, once it gets on site, it can all be preparations are low. So just finally, some use cases. So we've successfully unloaded a dehydrator in Australia. We entirely avoided the need for inert entry during that job, and we kept it under nitrogen for the duration until it got to the very end. At another case study, which was the gas shift reactor, this one we saw the catalyst heat up really quickly, and in fact we melted some of the prototype screws. We've taken the lessons to develop higher rating screws, and we've just developed some aluminium ones. But that highlighted the fact that I heard stories of people standing on the catalyst and just running for the ladder when things like this happen, to avoid it from melting through their shoes. We've done a job at a hydrotreater in Canada. It was a dense loaded vessel where the screws being able to break up that material was really important to get the even unloading. And then we've also done a mercury guard bed, which is obviously, just in the name, you can see how hazardous that kind of environment would be. More recently, we're doing a job in the US whereby, in fact, the refinery has adopted the use of Carol because it means less people on site with the COVID-19 restrictions. So that's a pretty quick overview of the Carol technology, and I'll be very happy to take any questions that you have.
Thanks, Chris. Very interesting presentation, and also very nice video to start with. I see we already have a couple of questions that came in via the chat, and I think more starting to come in. What I can do is I can just read them out to you, such that the people on the replay can also hear the questions. The first question is from Erwin, and he's asking, does the robot prevent people from going in the confined space completely, or do you still need to go in to perform the detailed cleaning with a person, that is?
So the Carol system is able to avoid having the person in there during the actual unloading of the catalyst step. In some cases, that means that you can avoid the inert entries, because by the time you've removed the great majority of the catalyst, you can shift the vessel over to open air. But as far as then doing inspections or cleaning after the unloading is complete, that would still be involve the traditional techniques. Again, you know, from a cleaning perspective, I'm not aware of too many automated technologies. I think there are a few, but obviously from an inspection perspective, that is also moving towards a lot of robotics in that space. Having, you know, with the traditional reactor setup, some of those still have internals that need to be removed by people. So that's another area where you might need to send somebody in to open up the internal manway to lower the Carol through. But in one of those examples, which I mentioned, we actually replaced the top internals with a floating mesh screen. And with that, you can remove the ceramics from above the screen with Carol. You can spear the screen and pull it out, and then you put the Carol in. So I guess, you know, the answer to your question is that we don't entirely eliminate confined space entry, but in many instances, we can eliminate the inert confined space entry, as in the nitrogen environment.
Yeah, I could imagine it's also a part that we see also with inspection robotics, where, of course, with the traditional designs, you're sometimes forced to deal with what you have, but it's more around also the new designs where you take into account that you run the inspection and these type of operations with robots, so that the design is capable of doing it completely without human entry.
Yeah, that's right. And actually, that's a bit of an advantage in that Advisian Digital is a part of Worley, and so Worley traditionally EPC, PCM, project management and engineering design. So we've actually been able to then go and influence the projects in their in the sort of project phase to have a look at the design of the vessels and to ensure that they're suitable as suitable as possible for the robotic catalyst removal. And that, you know, that means having top manways and not side manways, which is actually something we're looking to develop in any case. But it's also about, you know, avoiding internals that need people to go in to unbolt and things like you said there, Vincent.
All right, yeah, and I think the question from Martin is a bit related to this. He's asking, what if there are girders in the vessel? So I think that it all relates to the same topic, but perhaps there's something specific to mention there.
Yeah, there are different, I mean, different vessels have different challenges. You know, sometimes we have an offset manway, and that means that the robot has to move a lot further away on one side than others, which is an advantage of the screw robot sort of design, the rover, in that it can move all the way out. There are sort of some competitive robotic arms coming into the market that don't have that ability. The other thing is that by being sort of fully remote operated, the person operating the joysticks can see with the cameras various sort of internals, whether that might be a thermo well that they need to try and avoid, or other kind of sensors coming in, or girders, like you said. And if you and in those kind of multi-bed hydro crackers, that's where you're seeing probably the biggest challenge down towards the bottom of the trays. But at the same time, you're also seeing the largest quantity of catalyst. So even if you can't get all of the catalyst out towards the bottom, you can still get 80-90% of it out with the Carol, and in those sort of reactors, that can be sort of 16-20 hours worth of vacuuming.
All right, thanks for the further clarification. I think the next question is perhaps more related to a business opportunity. Gianfranco is asking if there's someone from in South America. There might be an opportunity within Petrobras. My suggestion would be, Gianfranco, that you connect with Chris after the webinar to discuss that in more detail.
Yeah, I guess the only comment I could have there is that we're set up in certain countries through where we have the actual robots, but we also move them to wherever they may be needed. So it really is available to whoever might be interested.
And a question I had before I move to the next one, which is actually related to this, Chris, is that you focus quite, of course, on the robot. Does that mean also, if you look at it at a global scale, that folks that are interested, that they can continue to work with their same contractors, same type of vacuum trucks, and the only part that you provide is the robot?
Yeah, so in the initial markets that we entered, which was sort of the US and Australia, our strategy there was to actually partner with specific catalyst handling companies that shared our vision of actually transforming the way that that catalyst handling is done. And that was important for us, and I think it's an important lesson for I guess anyone looking to develop a sort of automated tool in the maintenance kind of space, and that's getting the buy-in of the of the contractors that currently do the work, because without that, then you're kind of set up to fail. So that's where we, in Australia and the US, we're still under exclusive arrangements with catalyst handling companies in those regions. But in other regions, we have adopted a model whereby we can provide it directly to the client, or on a job-by-job basis to whichever catalyst handling contractor might be the usual catalyst contractor at that site. So we have our really good relationships with some catalyst handling companies that we're committed to, and but in other regions it's a bit more flexible.
All right, thanks. I think an important clarification for the whole practical side, of course. Another technical question from Juraj. What happens if the catalyst becomes so burned together that the screws are unable to move? Has this ever happened?
Yeah, this is something that's always been, part of the design criteria and considerations. One of the benefits of the screws is that they will help break up mildly clumped catalyst, and we've done various tests and had operations where that has been the case. But like you say, in other instances, the material can be so fused together that you need to send people in with jackhammers, or even the use of dynamite. There are other technologies around to try and break up that kind of material. And so at the present stage of the Carol development, where we get to that kind of situation, it's essentially a scope change. We pull the Carol out, and we'll do that. The catalyst handling company will do that the traditional way. So that's where we look to have a good communication with the client to identify whether the particular vessel is at risk of that, because that of course impacts on your contingency plan for having additional people, which in any case, you open a vessel that you're not expecting to have that kind of agglomeration, then it throws a lot of the plans out of the window anyway, because it can add significant time to the turnaround. We are continuously looking to develop the Carol equipment, and one of our key things is around additional tools to help break up fused catalyst. So that's something we'll be looking to be testing quite soon. I'd say that from, in certain regions, they run their vessels longer and harder and are more, and they might have certain types of crudes that are more susceptible to the catalyst being fused. And also but in a lot of the places that we operate, those kind of instances are in the minority. But we did have one at a dehydrator that was fused, and as I said, yeah, that was kind of a scope change.
Okay, thanks. And I think that that was also the last question. And in view of time, I would actually like to wrap up the Q&A. And first of all, Chris, I'd like to thank you very much for your presentation today. For all of you that have more questions or questions that pop up after the webinar, of course, feel free to contact Chris directly. You can do that via the email address that he's provided. You can also watch this webinar again in the replay on our site from tomorrow onwards. And you can contact Chris via the page in the technology catalog. Of course, also via ourselves if you get stuck. The email address is here. One last thing I would like to highlight is that next week we'll have another webinar, but be careful, it won't be on Tuesday this time, it will be on Wednesday, and it will be all around technologies that can help operators to reduce OPEX and CAPEX. Will be presented to my fellow managing partner, or by my fellow managing partner, Eric Nijveld. So hope to see many of you again joining for that webinar. For now, I'd like to thank you all for joining, and see you next time. All right.
Thanks, everyone.